Hello everyone, I'm Dr. Tejashwini N, Associate Professor. Welcome you all back to my YouTube channel Study with Tej. Today the topic is checksum. So what is checksum? Checksum is an error detecting technique that can be applied to a message of any length. At the source, the message is being divided into embeds and the generator creates an extra embed called checksum which is sent with the message. At the destination, the checker creates a new checksum from the combination of message and the sent checksum. If the checksum is all zeros, the message is accepted, otherwise the message is discarded. Once the new checksum is zero, it simply means that the message is uncorrupted, error free, and hence it is accepted. If not, some value except zero, if it is a non zero, then we say the message has been corrupted and we discard it. You will understand better with this example. Suppose whatever the message sent is a list of 5 4-bit numbers. That is, these numbers can be represented in 4 bits. For an instance, 0 1 1 1 will make 7. Likewise, 11 12 0 6, everything can be represented in 4 bits. So, if the message is a list of 5 4-bit numbers that we want to send to our destination, in addition to sending these numbers, we also send the sum of these numbers. For example, in this, 7 plus 11 is 18, 18 plus 12 is 30, 30 plus 0 is 30 again, and 30 plus 6 is 36. So, addition of all these numbers is 36. So, with these these numbers, we are also sending the sum of this message. So receiver at the receiver end, the receiver will add these five numbers, compares the results with the sum. If two are same, the receiver will assume no error and accepts all the five numbers and discards the sum. Otherwise, it treats it as an error. It is a corrupted message and it will discard that particular message. The message is not accepted. Then, while doing this, this is a very basic idea of how the checksum work, but actually how it is done, we'll have to learn more about it. So, we'll have to learn what is one's complement addition. Here in this example, one major drawback is each number can be written in 4-bit, but whereas 36 cannot be written in 4-bit because it needs 6 bits. It can be represented with 6 bits. So, but that is a problem here. So, one solution is that to use one's complement arithmetic. In this arithmetic, we can represent unsigned numbers between 0 to 2 to the power of m minus 1. It should be 2 to the power of m minus 1 using only m bits. If the number has more than m bits, the extra leftmost bits need to be added to the m rightmost bits. That is, we have to do the wrapping. You will understand the same thing here. As I said, 36 can be represented using 6 bits. Okay. Then changing that to 4-bit number would be something like this. That last 4-bit is anyway taken, that is rightmost is taken, the leftmost 2 bits is being added here. Once we add that here, 0 0 is 0, 0 1 is 1, 1 as it is, 0 as it is. So this will make the number 6 in decimal. So this is the binary equivalent. So that is how we are converting a 6-bit sum into 4-bit. That is by one's complement. So instead of sending 36 as a sum, we can send 6 as a sum with that 4 bits only instead of 6 bits, because as explained in the diagram, that is also of n bits. So all the messages are being splitted up into m bits, and even the sum is also of m bits. So that is being met here. So the receiver can also add the first five numbers in one's complement, and if the result is 6, the number is accepted, otherwise it is rejected. Same procedure. But still we want to refine it. We can make the job of the receiver easier if we send the complement of the sum, that is the checksum. If one's complement arithmetic, the complement of a number is found by changing all ones to zeros and all zeros to one. That is how we do, changing zeros to one and ones to zero. That is the complement of a number. This is nothing but this is same as subtracting a number from 2 to the power of m minus 1. Correct? So in one's complement arithmetic, we have two kinds of zeros. One is positive zeros and one is negative zero, which are complement of each other. So positive zeros has all the m bits set to 0, but whereas negative 0 has all the bits set to 1. If we add a number with its complement, then we get a negative 0. So adding any number, for an instance, 6 and complement of 6 is 9. If we add those two, then we will get negative 0. Okay, negative 0. When the receiver adds all the five numbers, it gets negative 0. The receiver can complement that and make it as a positive 0. And hence, if it is 0, the message is error free, uncorrupted, and hence it is accepted. So, this is the logic. You will understand better with the example. See here, the sender, as earlier said, the sender adds all the five numbers in one's complement to get 6, and then sender sends a complement of that result, that is complement of 6 is 9. Okay, that is, otherwise it can also be taken as 15 minus 6 9, or else the value of 6 is 0 1 1 0. If you convert this 0 to 1, this 1 to 0, again this 1 to 0, and this 0 to 1, you get this number. Equivalent of this number is nothing but 9. Either way, by taking the complement, we get 9 is the complement of 6. So instead of sending 6, we are sending 9 here. If there is no corruption in the transmission, the receiver receives the same thing and then adds them up in one's complement to get 15, because again one's complement addition of this answer is 6 only. 6 plus 9, it will be 15 only. Then complementing that 15, that is 1 1 1 1 is the equivalent, binary equivalent of 15. Complementing that will become 0 0 0 0 is nothing but 0. So once it is 0, it simply means the message is uncorrupted, error free, and hence it is accepted. If it was an some non-zero value, then it is corrupted and hence it is discarded. So in figure you will understand it better. If you can see here in the figure, you will understand it better. The sum of all these, okay, initially checksum is taken as 0, then sum of all this will be 6, then actual checksum sent to the receiver is nothing but 9. Okay, so once this is sent, again at this end we are calculating the checksum of this and also adding that checksum to this one, then it becomes 15, and complement of that 15 is 0. So here, since it is 0, it is error free. Thanks for watching. Have a good day.